to start talking about 3.4 a little bit, which is inverse functions. Inverse functions, there's steps to finding inverse functions. Basically, you switch x and y and solve for y. So this might have been called f of x equals this, or y equals this. I usually draw a line and then switch x and y. So wherever the y is becomes an x, wherever the x is becomes a y. Now that's step one. I switched x and y. Now I'm going to solve it for y. I'm going to add 5 and divide by 3. So that could be called 1/3 x plus 5/3. Now, if you're doing it with the function f, sometimes you'll see f with a -1. That means f inverse. So what I'm going to do is I'm going to graph these. 3x minus 5 has a y-intercept of -5. You would rise 3 and run 1. So I think that makes this point and this point. And I would make a line. You could rise another 3, run another 1. And that would give me a point 2, 1. So you have this for your line of f. Now the line I just found down here, I will graph in red. Its y-intercept is 5/3 or 1 2/3. I would rise -1 and run 3. So I believe that makes this line like this. And this is f inverse. Now, I would again try to make sure that you're aware that all inverse functions, if I had graphed it correctly, should be symmetric about y equals x. I don't think I did a very good job in my graphing here, but they should fold on the line y equals x. This is example 1 on section 3.4. They do not ask you to graph it. I was just trying to show the illustration and how you could just switch x and y. I teach all mathematics through inverse function, whether it's pre-algebra or calculus 3, it really doesn't matter. They all are taught using inverse functions. What's the inverse of subtracting 1? That would be adding 1. What's the inverse of multiplying by 3? Well, that would be dividing by 3. What's the inverse of the square? Well, that would be taking the square root. If you take a square root in an equation, don't forget to put plus or minus. But inverse functions extend all the way to the trig functions sine and arcsine. In calculus, you get derivatives and integrals. But everything in mathematics can be thought of as something and its inverse. Okay, the assignment's going to be 3 to 39 odds. We'll do a couple of them. They want us to find the inverse functions. To find an inverse function, you replace the y with an x and the x with the y. In other words, you reverse the x's and y's. So this y becomes x, this x becomes y. So, and then you solve it for y. So add 1 and divide it by 4. So whether you write it this way or whether you write it this way, I know they're equivalent. I hope you do. Now those are the inverses. So they might call it y with a little -1. The little -1 simply means inverse. How about number 7? Can we switch x and y here? So now the y becomes an x and the x becomes a y. Solve it for y. So you would subtract 7 and divide by 12. Again, whether you write it that way or this way, it means the same thing to me. They're both lines. Again, these are the inverses, so it might call it y with a little -1. These say to verify that they are inverse functions. You could do them two ways. You could actually find the inverse. Right now this says this. To find the inverse, you switch x and y, and solve it for y. And you'd get that by subtracting 4. Does it appear to be the inverse? Yes. Or you could do a composite function, f of g of x. What is the f function? Well, it's x plus 4. You replace the variable with the other expression. Does that leave you just x? 3 dots in a triangular pattern like this means therefore they are inverses. So you could actually find the inverse and see if it matched, or you could do a composite and see if you just get x. Either one would work. I hope these help. Good luck.